Acids and bases. The essential questions are: how can you identify an acid-base reaction, and how can you predict the products of an acid-base reaction? So, if you have an acid and a base, it's going to create salt and water. So we'll look at some examples so you can see how this works. First we'll talk about real quick that if we have a strong acid and a strong base, that's going to make a neutral salt, and the salt will have a pH of 7. When we say salt, we don't necessarily mean table salt. An ionic compound is considered a salt in chemistry. A strong acid and a weak base is going to make an acidic salt, which means the pH will be less than 7. And a weak acid with a strong base will make a basic salt, which means the pH is greater than 7. So some examples of this: hydrochloric acid neutralizes sodium hydroxide. So we have the acid, which is HCl, and the base, which is NaOH. So they're going to do a double replacement reaction. They're going to switch places, and that's going to give us Na with Cl, which really is table salt in this situation, and water, because the H will combine with the OH. So now if we look at this, hydrochloric acid was one of our strong acids. NaOH is one of our strong bases. So strong acid plus strong base makes a neutral salt. It's called sodium chloride, and I put an N for neutral. Okay, let's look at the next one: acetic acid and calcium hydroxide. Acetic acid is HC2H3O2. Calcium hydroxide is CaOH 2. Okay, we're going to switch places in a double replacement reaction. So the calcium is the positive. It will go with the negative on the other one, which is the acetate. We need to balance out the charges. Calcium's a +2, acetate's a -1, so we cross over. And then we get H with OH, and so we have water. Okay, we're going to go ahead and balance quickly. We have 2 acetates, so we have to put a 2 in front there. And that's going to end up giving us 2 waters. Okay, so now that we have it balanced, let's look at our acid and base. Acetic acid is not one of our 6 strong ones, so it's a weak acid, but calcium hydroxide is in group 2, so that makes it a strong base. So weak acid plus strong base makes basic. Calcium acetate is the salt. It's called basic. Okay, so then we have ammonium hydroxide and sulfuric acid. Ammonium hydroxide is NH4OH, so that's actually our base here, and sulfuric acid is H2SO4. So we're going to switch places. So we have NH4SO4, and NH4 is a +1, SO4 is a -2, so we need to cross over. And then we get hydrogen with OH, so that makes water. Okay, so real quick, let's balance this. We need a 2 here because we have 2 NH4s, and then that leaves us with 2 waters. Okay, so now that we're balanced, let's go ahead and look at what we've got. NH4OH was a weak base. It's not in groups 1 or 2. H2SO4, however, is a strong acid. So a strong acid with a weak base is going to leave us with an acidic salt, and the salt here is ammonium sulfate. Okay, aluminum hydroxide and nitric acid. Aluminum hydroxide is AlOH3, that's a base, and nitric acid is HNO3. We're going to switch places, so my aluminum is going to go with my nitrate. Aluminum's +3, nitrate is -1, so we need to cross over, and then we end up with water. Okay, let's go ahead and balance. We need 3 NO3s, and that actually gives us 3 waters. And there we go, we're balanced. So let's look at our acids and bases. Aluminum hydroxide is a weak base. Nitric acid is a strong acid, so we're going to end up with an acidic salt, and it is aluminum nitrate.